Hi everyone, we're going to continue with inverse trig compositions, which is how we ended the last lesson. Remember things you'll need today. You'll need to be able to look at a unit circle so that we can find the different angles that we need. You don't need a calculator today though. So for a composition, remember you're always starting with the inside part of the expression and then you're going to work your way outside. So for the one that we see here, we're going to start by trying to figure out what tangent of pi over 2 is. And then once we find tangent of pi over 2, then we can find the inverse sine of that angle. Now notice tangent of pi over 2 does not say inverse tangent of pi over 2. It just says the tangent at pi over 2, which means I need to go to my unit circle, right, and I need to find the tangent here. Now if you remember tangents, find a different color to use. Tangent is found by doing the y over the x of the point. So if I look at my unit circle at pi over 2, which is 90 degrees, if I did the y over the x, I would get 1 over 0. And 1 over 0 is undefined because you can't divide by 0. Now, if the inside of the expression is undefined, we're done. We don't even have to continue. We don't have to find inverse sine of anything that's undefined. Our answer is just, it's not defined. For the second one, again, we're going to start by working on the inside first. This says cosine of pi. Now again, notice it doesn't say inverse cosine of pi, it just says cosine of pi. So we're going to look on our unit circle. We're going to go over to pi, which is 180 degrees, and we're going to find the cosine here. And remember, the cosine is simply just the x value of the point. Okay, so when I look at 180 degrees pi, the x value of the point is just -1. And then once we find the value of the inside part of the expression, then we can work our way outside. So our step 2 would be to do inverse tangent of the answer that we just got. Now remember when we were talking about inverse tangent yesterday, inverse tangent, inverse sine, inverse cosine were only defined on certain part of the unit circle. And for inverse tangent, that is from 0 to -90 and 0 to +90. And the only place it would be undefined there would be at the actual endpoints, but we don't have to worry about those. So we want to look from -90 to +90 for a tangent value of -1. And remember, tangent is found by doing the y over the x. So I'm looking, where can I do a y over x from -90 to +90 and have it be equal to -1? Based on the fact that it's negative is kind of a good hint, because if I did the y over x here, all of these would be positive. So looking down here is really where I want to look. So if I did this y numerator over this x numerator, that's not -1. If I did this y numerator over this x numerator, that is -1. You can actually see my scratch work from the lesson yesterday. So remember what we can't write down. We cannot write down 315 degrees. Because our domain is from -90 to 90, 315 is not in this domain. So we have to write down something that's equivalent to 315, but in the right domain. And that is going to be going backwards 45 degrees. Okay, so the final answer to this would be -45 degrees, or in radians it would be -pi over 4. Okay, for the ones in the next section, let me scoop my paper. Okay, I'm going to start with the inside part. Remember, arc sine is just a fancy way of saying inverse sine. Inverse sine. Okay, so an inverse sine is one where we would have a restricted domain. So we do need to think about, where does inverse sine exist? An inverse sine exists kind of in the same place as inverse tangent. It was -90 to +90. But it does exist at the endpoints, unlike inverse tangent. Okay, so we're looking for an angle that would have a sine value of 1/2 between -90 and +90. And remember, the sine value is found by just looking at the y value of the point. Okay, so looking -90 to +90. The fact that it's positive is a good hint because the y values are negative down here, so I probably want to look up top somewhere. for a sine value of 1/2, and that's going to be right here at pi over 6, or 30 degrees. Okay, equals 30 degrees, or pi over 6. And then once we have the inside answer, remember after that, then we're going to switch and we're going to do the outside part of it. And the outside part of it is to find the tangent of this angle. So then we'll do tangent of pi over 6. Tangent, not inverse tangent, just regular old tangent, means we want to go look at pi over 6 and we want to do the y divided by the x there. So I'm going to go look at my unit circle. Here's pi over 6. And remember, you only have to use the numerators when you do this. So I'm going to take the y numerator over the x numerator. That's 1 over square root of 3. And then we're going to rationalize this. To rationalize it, remember you multiply both the numerator and the denominator by the radical you're trying to get rid of. So if we multiply on the top, we would get square root of 3. And if we multiply on the bottom, that would become square root of 9, which is just regular 3. And that is our ending answer. Okay, looking on the right side. Okay, inverse tangent of square root of 3 is the inside part. And that is inverse tangent, that's not regular tangent. So remember, inverse tangent is restricted to -90 to +90. It just doesn't exist at the endpoints. So we're looking for an angle that would have a tangent of square root of 3. And remember, tangent we've had a few tangents already. That's the y over the x. Okay, it's also positive, so that kind of gives me a hint that it's probably not going to be down here, because if I did the y over x here, I would get a negative number. So I'm going to look at y over x in this quadrant, and I'm going to try and see where do I get square root of 3. So this would be 1 over square root of 3. This would be square root of 2 over square root of 2. And this one would be square root of 3 over 1, which is the one we need. Square root of 3 over 1. Oh, I didn't look and see what the angle was there. Square root of 3 over 1, that's 60 degrees, which is pi over 3. 60 degrees or pi over 3, however you want to say it. And then after we have that, we can take that answer and then do the secant of that answer. Secant of pi over 3, and that's not inverse secant, that's just regular secant. And remember, the secant is a reciprocal trig function. This one would be the reciprocal of cosine. So it's kind of like taking a cosine and flipping it over. The cosine itself is the x value of the point. So it would be basically like taking the x value of the point and flipping it over. So we're going to go to pi over 3 on our unit circle. Right here. We're going to take the x value and flip that over. So if I flip over 1/2, I just get 2. 2 over 1, which is 2. Ta-da! Let me autofocus briefly. Okay, if I scoot it down, okay, looking at what we have next, inverse cosine of -√2, and then we'll do sine of that value. So again, I'm going to start on the inside, and this is inverse cosine, and remember, inverse cosine does have a restricted range. Inverse cosine is the one that's on the top half of the unit circle from 0 to 180. So we're looking for an angle that would have a cosine of -√2 over 2. And remember, cosine is the x value of the point on a unit circle. So I'm looking at all of these x values of these points for one that is negative, so it's definitely over here. So that would be 135, which is 3 pi over 4, has that cosine value of -√2 over 2. 135, or 3 pi over 4. Was it 3 pi over 4? Yes. Or 3 pi over 4. And then from there, once we know the answer to the inside part, then we'll do sine of this answer. So then we'll do sine of 3 pi over 4, which is not an inverse trig function, it's just sine. So we're going to look at 3 pi over 4, and we're going to find just the sine value here. Remember, the sine value is the y coordinate, the y value of the coordinate. So looking here, the y value would be square root of 2 over 2. Equals root 2 over 2. Okay. Last one of these little guys, we have cotangent of cosecant of 2 root 3 over 3. So again, I'm just going to start on the inside. Inverse cosecant of 2 root 3 over 3. Inverse cosecant. Okay, inverse cosecant, because it is an inverse, it does have a restricted range. A lot of people have trouble remembering those because we didn't see the graphs of those, but inverse cosecant would have a range that is very similar to inverse sine. And remember, inverse sine is just backwards 90 and forwards 90. Okay. The only place it doesn't exist is actually right here at 0, but we don't need to worry about that when we find a value. So this is the reciprocal of sine. So if we think about it, it would be 1 over the y value that we're looking for, basically taking the y value and flipping it over. So we're going to look on our unit circle, backwards 90 and forwards 90, for an angle that if we took the y value and flipped it over, we would get 2 root 3 over 3. And the fact that it's positive does tell me that I probably need to look in the first quadrant. Again, flipping over the y value. So if I flip over this y value, I'm not going to get 2 root 3 over 3. If I flip over this one, you would get 2 over square root of 2, which you could rationalize, but you're still not going to get a 3 from anywhere. But if you flip over this one, that's where it comes in handy. We'll have 2 over root 3, and then you'd rationalize it and get 2 root 3 over 3. So that angle would be pi over 3, or 60 degrees. Pi over 3, or 60 degrees. And then from there, we'll do the outside part, finding the cotangent of this angle. Cotangent of pi over 3. And that's not inverse cotangent, it's just regular cotangent. And remember, cotangent is the reciprocal of tangent. Tangent is y over x. So cotangent is the x over y. And you just have to use the numerators because the denominators always cancel. So when I go look at pi over 3, if I do the x numerator over the y numerator, I would get 1 over square root of 3. And then 1 over square root of 3 rationalizes. You'd multiply by the radical you're trying to get rid of. And that would give you 1 times root 3 on the top. And on the bottom it becomes square root of 9, which is just regular 3. Okay. We still need the unit circle just for a little bit on the bottom, but more trying to figure out where things are positive and negative, so not to find actual angle values. So the next section says, what if it's not a unit circle angle? So when you look at both of these, okay, we have inverse tangent of 3/4 and inverse sine of negative root 2 over 3. This is not in any of the points on the unit circle, and this is not in any of the points in the unit circle. There's similar to this, but this itself is not on the unit circle. So anytime you're having to find the inverse trig value of something that's not on the unit circle, your best bet is to draw a triangle where the inverse function is allowed to exist. I'm going to write that down. We're going to draw a triangle. In the allowed region, so basically in the correct range. I'll say region. Okay, so when I look at the first one, okay, it says inverse tangent of 3/4. So I know that I'm going to need to draw a triangle somewhere where inverse tangent exists. So I'm just going to draw a quick little coordinate plane, nothing on it really. Inverse tangent is allowed to exist from negative 90 to positive 90. So I'm going to put check marks there just to remind myself that this is where inverse tangent is allowed to exist. Now more specifically, where the inverse tangent would be positive would be here. The inverse tangent would be negative right here. Because if we go look at all of those tangent values, if I did y over x, y over x, y over x, they're going to be positive here. But if all of these in quadrant 4, they end up being negative. So this triangle needs to exist in this quadrant, because in this quadrant is not only where inverse tangent exists, but also where your inverse value here would be a positive number. So I'm going to draw myself a reference triangle, and remember, a reference triangle always connects back to the x-axis, and then you'd have a reference angle that pairs with the x-axis. Okay, when you're given a tangent value, you're actually given some side lengths. If we go way back to the very first day we learned about trig ratios, we learned the old SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, which is telling me some side lengths for this angle. Okay. So for this angle, I know that the side opposite from it measures 3. And I know that the side adjacent to the angle measures 4. From there, I can work on finding the secant. Okay? I technically don't even need to figure out what this angle is because my ultimate goal is to just find the secant of whatever this angle is. Now, if you remember, secant is the reciprocal of cosine. Reciprocal of cosine. Okay, so if we're thinking about the trig ratio for cosine, cosine was the CAH. Cosine is adjacent over hypotenuse. So if cosine is adjacent over hypotenuse, then secant of the angle would be the hypotenuse over the adjacent. Okay. So for this angle, I can see the adjacent side is here, but I don't know the hypotenuse yet, so that's going to be my first goal. Now, if you remember back to geometry, 3 and 4 for the legs always creates the same hypotenuse. That's what's called a Pythagorean triple. 3, 4 will always pair with 5 for the hypotenuse. If your 3 and 4 are somewhere else, like if you have a 3 on the hypotenuse and a 4 here, then it's not necessarily true. But if 3 and 4 are the legs, then the hypotenuse is the longest side. So now that we know the hypotenuse and the adjacent side, we can find the secant of whatever this angle was. So my secant of the angle is just the hypotenuse of this angle, or hypotenuse of this triangle, which is 5, over the adjacent side, which is 4. Now, when we took the quiz last week, I saw a lot of people get this question wrong. Well, not this question, but get very simple trig ratios wrong. So what they did wrong is they then maybe typed this in the calculator with inverse secant, and that is not what we want to do. If you're asked to find secant of an angle, it's just a ratio. It has nothing to do with angles. It's just the ratio. So we don't want to turn this into a decimal. We don't want to type it into the calculator. We want to leave it just like it is, as just a ratio of the side lengths of the hypotenuse and the adjacent side. Okay, looking at this one, okay, inverse sine, it's kind of the same thing. This is not any point that you're going to find on the unit circle. So then what you have to do instead is draw a triangle where inverse sine is allowed to exist. Okay, so if I think about the coordinate plane, inverse sine is allowed to exist from -90 to +90. So that's going to be down here or up here. And then we can really narrow it down to where this triangle is based on the fact that the sine is a negative ratio here. Because this is a negative ratio, if we look at our unit circle, the only place where sine is negative would be in quadrant 4. The sine is not negative in quadrant 1, which is the other place inverse sine is allowed to exist. So this triangle has to be in quadrant 4 in order to end up with a sine of a negative ratio right here. So I'm going to draw a reference triangle in quadrant 4, which will connect back to my x-axis. Your angle is always going to be the one between the terminal side and the x-axis. There's my angle. And remember, just like I showed you on the last one, once you have a triangle, the sine here is giving you some side lengths. So going back to your SOHCAHTOA, sine would be opposite over hypotenuse. So this top number is opposite. This bottom number is hypotenuse. Now when we think about what we're labeling on here, one of these has to be negative because we went right and down. So if you go down, this number has to be the negative one. So when I look at these, when I write the opposite, I don't want to write square root of 2, I want to write negative square root of 2. And then my hypotenuse would then be 3. And from there, we're asked to find the cotangent of this angle. Now again, just like the last one, it doesn't really matter what the angle is. All we need to do is find the cotangent of whatever that angle was. So cotangent, remember, is the reciprocal of tangent. Reciprocal of tangent. And tangent is opposite over adjacent, which means cotangent of the angle would be the adjacent over the opposite side of the angle. So if we go look at what we have the opposite side, but we don't have the adjacent side. So we will need to find the adjacent side first. I'm going to do a little Pythagorean theorem down in the corner to find my adjacent side. I'm going to call it A for adjacent side. So we'll have a squared plus negative root 2 squared equals my hypotenuse squared, which is 3 squared. So that's a squared. If you square a negative, it's going to turn positive, and if you square a square root of 2, it's going to turn into a regular 2. Equals 3 squared, which is 9, which means a squared is 7, which means a is square root of 7. Okay. So now we know a is square root of 7. I'll label it. And because it goes to the right, that is a positive number, so we are right to write down the positive number. So now I can find the cotangent of this angle. So remember, cotangent is going to be the adjacent side to the angle, which is going to be square root of 7, over the opposite side from the angle, which is negative square root of 2. And this does rationalize. To rationalize it, you're just going to multiply the top and bottom by this bottom square root that you're trying to get rid of. So on the top, those would recombine and become square root of 14. And on the bottom, we would have negative, and then root 2 times root 2 becomes regular 2. And this does not simplify more than that because the 2 does not go into 14 because the 14 is trapped in a radical. Now again, most common mistake when people were doing trig ratios on the quiz last week is they then grabbed their calculator and tried to turn it into a decimal. Don't do that. It should look like a ratio. I saw a lot of people try and do inverse here to try and find an angle. Don't do that. We don't need the angle. We just need the cotangent of the angle. So we're going to leave it just like this. All right. What's on the back? It's always a surprise. Oh, finding the measure of an angle. Okay. So we're told to find the measure of angle theta if the sine of theta is negative 3/4 and the tangent is positive. So our ultimate goal is to find the measure of the angle. And some little things that'll help us figure that out is we know the sine. Ew, I thought I grabbed my pink highlighter. Pink highlighter. Okay, we know the sine is negative 3/4, and we also know the tangent is positive. Now, I know you're looking at this going, does this look like Pythagorean identity questions? Close, but not quite. Pythagorean identity said something like, find the cosine if you know the sine. So slightly different. This one is asking us to find the actual angle if we know the sine and we know tangent is positive. So first thing we gotta do is figure out where this angle is. Okay. I'm gonna use just a little coordinate plane. This little guy here. And I have two clues. My first clue is that tangent is positive. So I'm going to look at my unit circle, and I'm going to go figure out where is tangent positive. Okay, tangent, remember, is basically the y divided by the x. So I'm going to look on my unit circle, where is it going to be positive if I do the y divided by x? Ooh, there it is. It'll be positive here if I do y divided by x. It won't be positive here in quadrant 2 because those will be negatives. It'll be positive here because these will turn into positives. So that's quadrant 1 and quadrant 3. Okay. Another clue I have is that the sine is a negative number. Okay. So it has to be one of these two. So that's the next thing I'm going to check. Where is sine negative? Is sine negative in quadrant 1? Nope. Is sine negative in quadrant 3? Yes. So we now know that this triangle is in quadrant 3. So I'm going to draw it. Draw myself a little triangle. Now, what we're trying to find is the measure of angle theta. Now, here's the tricky part. Let me draw it. Okay, we actually don't even need a triangle on this one. Let me get rid of the triangle. Just keep it as an angle, not a triangle. Okay, there's my angle. What we are trying to find is this entire angle here. This is our angle theta. Okay? But all we're going to be able to calculate right now is our reference angle. Okay. The little reference angle is this angle right here. That's our reference angle. Usually we call that theta ref. Theta ref. Okay. So what I'm going to do, I'm going to start by just saying, well, I know the sine of theta is -3/4. Okay. I'm going to use my calculator. I did lie to you. We do need a calculator. Sorry about that. I'm going to use my calculator to help me figure out my reference angle. Because if I were to cancel sine using inverse sine, it's going to give me my reference angle. So inverse sine will cancel sine. We'll do that same thing over here, inverse sine. And again, this is not on the unit circle, so we can't just look on our unit circle for inverse sine. I'm going to first make sure my calculator is in degrees. It sure is. That's under mode. And then I'm going to type inverse sine of -3/4. -3/4. Okay, and this should be my reference angle. Now, reference angles are always positive, because it's kind of more just a measure of distance than it really is like direction of the angle. So my reference angle, which would be theta ref, is equal to this, but positive, 48.59. 48.59 degrees. So if we need to find the entire theta, well, the entire theta first goes to 180 and then continues that extra 48.59 degrees. So my actual theta is 180 plus that little reference amount that we found right here, 48.59 degrees, which is 180 plus 48.59, 228.59. That is our entire angle. Tricky. All right, up next, find the measure of the angle. So again, looking for the angle measure. And we know the cotangent. Cotangent is -√2, and we're told the sine is greater than 0, so sine is positive. So again, first thing I'm going to do is just figure out where the heck this angle is. Okay, so I'm going to draw a little coordinate plane. And I was given 2 clues. First clue I'm given is that sine is positive. Sine is positive in 2 places. Sine is positive in quadrant 1. Sine is also positive in quadrant 2. Everywhere else it's negative. I'm going to check here, check here. Okay, I'm also told the cotangent is negative. So this was quadrant 1 and 2. A negative cotangent, so like that's the x over y. So looking at my unit circle, where is the x over y negative? Is it negative here if I did x over y? No. Is it negative here if I did x over y? Yes. So it has to be in quadrant 2, because that's the only place where both of these are true. So I'm going to just draw the ending part of the angle here. Okay. Now again, the angle that we're trying to find is the angle that goes from this initial ray on the positive x-axis all the way to this terminal ray. This is our actual theta. But when we use our calculator to do this, it's not going to be able to find that. It's going to find your reference angle instead. So it finds this little guy. The reference angle is always the angle between the terminal ray and the x-axis. That's our reference angle. Okay, so I'm going to start with the fact that we know the cotangent of the angle is -2. If I know the cotangent, I don't have a way on my calculator to type inverse cotangent, but if I know the cotangent is -2/1, well then that tells me the tangent is just the reciprocal of this, which would be -1/2. And then I can do inverse tangent to find my reference angle. So from here, to cancel tangent, I'm going to do inverse tangent, inverse tangent. Make sure your calculator is still in degrees. Inverse tangent of -1/2. And this should tell me my reference angle. And again, reference angles are always positive, so you can just drop that negative right off of there, because it's just a measure more of distance, not of direction of the angle. So these will cancel, and we'll be left with our reference theta is 26.57. I'm going to round to 26.57. Okay. Now to find actual theta, it's different than the last one. On the last one, our angle was down here, so we had to do 180 plus the reference angle. On this one, our theta is right here. So if we went all the way to 180, that would be a straight angle. But we're going to have to take away the reference angle part of it, so we're going to take away the 26.57 to find our actual theta. So our entire angle is going to be 180 minus the 26.57. And 180 minus 26.57 is 153.43. 153.43. Ta-da! Okay, last little section, we're going to solve some little baby trig equations. And anytime you solve a trig equation, they're going to tell you the range that you're allowed to look in, or the domain you're allowed to look in. So on this one, it says solve each equation if theta is between 0 and 2 pi. So our angle is between 0 and 2 pi. Or angles, could be two answers. So I'm going to start by isolating sine on here. To isolate sine, I'm just going to divide by -8 on both sides. Divide by -8. Where'd my blue pen go? Okay, that gives me sine of theta equals, this would reduce to √2 over -2. Okay, so now what we're going to do to find the actual angle, technically you could use inverse sine here. I don't want you to get confused about looking in the correct range, because we need to look in this part of the unit circle, which is basically the entire unit circle. So we want to look in the entire unit circle for any angles that would have a sine value of √2 over -2. Are there any angles in the entire unit circle, 0 to 2 pi, that would have a sine value of √2 over 2? And remember, sine value is just the y. So I'm going to look here, -√2 over 2. All of these are positive, so we don't want to write these down. Here, all of these signs are also positive. I don't want to write those down. Here, there we got our first one, 5 pi over 4, which is 225. 225 or 5 pi over 4. And this could have more than one answer because we are allowed to look in the entire unit circle for these. So if I keep looking at all those y values, I'll notice another one over here. This one would be at 315, which is 7 pi over 4. So this equation has two answers because we were allowed to look in the entire unit circle. Okay. Second one, my angle is on the right-hand side attached to cosine. I'm going to start like I did on the last one. I'm going to start by isolating cosine by dividing by this -8. Okay, and again, we end up with a situation where we can reduce. This 4 over -8 would reduce, and we would have square root of 3 over -2 left. And again, you can think about this as doing an inverse cosine. I don't want to necessarily write that down because I don't want you to accidentally think like, oh, I need to only look on a certain part of the graph. We're allowed to look from 0 to 2 pi. So we're looking for any angles from 0 to 2 pi that have a cosine of √3 over 2. Any angles from 0 to 2 pi that have a cosine of √3 over 2, of -√3 over 2. All of these are positive, so it's not going to be here. Looking over here, I have one here, 150, which is 5 pi over 6. And then looking to see if there's any others that have a cosine of -√3 over 2. Right here, 210, which is 7 pi over 6. Both of these are allowed because we were told initially that we can look from 0 to 2 pi. Okay, and then last little guy here, negative tangent of equals 1. So again, we're trying to solve this equation for the angle. First thing I want to do is I want to isolate just tangent of theta. So I'm going to cancel that negative by dividing by a negative. Okay, that leaves me with tangent of the angle equals -1. Okay. Now again, to find the actual angle, we need to look for places on the unit circle that would have tangent values of -1. And remember, we're allowed to look anywhere from 0 to 2 pi. So looking 0 to 2 pi for anywhere that would have a tangent of -1. Tangent, remember, is found by doing the y over the x. So if I do any of these y's over these x's, those are all going to be positive. But if I look here, this one would be equal to -1. That's 135, which is the same as 3 pi over 4. And then checking if there's any others where the tangent would be -1. All of these tangents would be positive in quadrant 3 because a negative over a negative would turn positive. But here, we would have this one right here. If we did -√2 over +√2, that would be -1. And that was at 7 pi over 4, which is 315 degrees. And then last up for today is a practice AP question. It is one of these equations. Okay, it says, what are the solutions to the equation 2 sine of theta plus square root of 3 equals 0 when when theta is from 0 to 2 pi. So this again is telling us where we're allowed to look on the unit circle. So we don't have any kind of restricted range. We can look from 0 to 2 pi, which is all the way around. I am going to start like I did on the last one by isolating the sign. This one has 2 steps. I'm going to start by subtracting square root of 3 on both sides. And that gives me, oh, I crossed it out in the wrong place. That gives me 2 sine of theta equals 0 minus √3, which is -√3. And then if we divide by 2 to isolate sine, we would get sine of the angle equals -√3 over 2. So we need to find any place from 0 to 2 pi where the sine value, the y value of the point, is -√3 over 2. So looking at my unit circle, for all those y values, looking for negatives, none of these are negative. Looking at these, none of these are negative. Looking at these, ooh, we have one here, 4 pi over 3, which is 240. 4 pi over 3. And we also have any other sine values would be -√3 over 2. This guy, 5 pi over 3, which is 300. And that matches B. All right, guys, I hope we learned something today.